This week we are going to be covering Module 6 on factoring. Now this is a very important aspect in algebra, as if you don't understand the factoring, the solving of equations and the more in-depth algebraic concepts will not go as smoothly for us. So I'm going to go through, we have several different types of factoring, and I want to go through all of those in short little snippets with focusing on one concept per little video. And we'll do lots of practice problems. So this is Module 6, Factoring. The first type of factoring that you should always look at whenever the directions say to factor is we should always look for the greatest common factor. This is a number that multiplies into all of our terms. Okay, once again, we're going to be using those terms and factors. We need to know those definitions. Terms are the stuff that's added, factors are the stuff that's multiplied. So we are looking for the greatest common factor first and foremost always in factoring. Let's go through some examples. In a problem like this, we want to know what goes into both 18 and 27. Now we could say that 3 goes into both of those. But 3 is not the greatest or the largest factor that they share. Think larger. Sure enough, 9 is the largest number that goes into both 18 and 27. So I'm going to be pulling out a 9. Now when we take out the greatest common factor, this is using our distributive property backwards. Instead of multiplying something in, we're pulling something to the front and writing the problem as a factors, or things that are being multiplied. Now 9 is the greatest common factor between the numbers 18 and 27, but we have variables, and variables can have common factors as well. The greatest common factor between x cubed and x squared is x squared. Can't pull out more than what you got, and I only have 2 x's being multiplied over here, so I can't take out more than that. Now, if I pull out the 9x squared, I'm taking the 18 and I'm pulling out or dividing out the 9, leaving me with a 2. I had 3 x's here. I pulled out 2 of them. That leaves me with 1 x left. So the first term, instead of being an 18x to the third, becomes 2x. Multiply it back in to make sure. 9 times 2 is 18. X squared times x. Multiplying like bases, we add the exponents. There's always a 1 up here. 2 plus 1 is our 3. Then we have our second term. Terms are separated by addition or subtraction. Have to put a plus sign to separate our terms again. 27 divided by 9, or pulling that factor of 9 out, leaves a factor of 3. X squared, pulling out both x squares, leaves me with no more x's left underneath. So this is your answer in factored form. It's in factored form because I have something times another quantity. Factored form. Let me talk a little bit more about those variables. The greatest common factor when it comes to variables is your smallest exponent. The greatest common factor when dealing with variables is the smallest exponent. The greatest common factor when dealing with your variables is going to be the smallest exponent, because that's the most that you can pull out is the smallest amount. Okay? Let's do another example. In this example, we have 2 numbers, 10x cubed minus 4x squared. The greatest number that goes into both of those, I always break them apart. I look at my numbers separately, then my variables. My numbers are 10 and 4. Those are both even numbers, and so the greatest common factor is 2. Once again, for my variables, the greatest common factor is the smallest exponent. So it's x squared. Don't forget the base number that goes with that exponent. If I pull out the 2x squared, 10 divided by 2 is 5. X cubed, I take out 2 of the 3, I'm left with 1. Minus 2. The x squares are gone. You can always check your factoring by multiplying back inside. 2 times 5 is 10. X squared times x is x cubed. 2 times 2 is 4. And the x squared comes along for the ride, and I still have my minus. So there's my answer for that one. Let's start another one. 6x cubed minus 3x squared plus 12x. Now here we just have a third term, but the same thing goes. The common factor has to be common in all 3 terms. It's all or nothing. So the greatest common factor of 6, 3, and 12 is 3. The greatest common factor of our variables is the smallest exponent, so it's that x, which is, once again, x to the first power. If I pull out, now remember when you're pulling out the 3, you're not subtracting it, we're dividing it to the front because we're doing the opposite of that multiplication or distributing inside. So 6 divided by 3 gives me a 2. I have 3 x's here, I take out 1, I'm left with 2. Minus, I took the 3 out, so I'm left with a 1, not 0. Whenever you're dividing, you're left with a 1. There were 2 x's, I took one of them out, so I'm left with 1x. Plus, 12 divided by 3 is 4. And I had 1x, and I took 1 out, so there's nothing left over. And we're done with that. Now let's do a little bit more of a challenging problem. Now this problem's a little bit scarier looking. It's really confusing to see how many terms we have and what they are. You have to remember that the definition of a term is a number, a letter, or a product, or multiplication, of number and letters, or your variables, separated by addition. So in this problem, x squared is being multiplied by this ugly quantity, and then that term is ending because of the plus sign. So this is one term. Then I have 5 times this other quantity. Once again, that whole thing is one term of this expression. Now, in each term, we have different factors. In the first term, factors are the stuff that's being multiplied together. So what's being multiplied? I have x squared, which can be represented as x times x. And then it's being multiplied by this quantity. So this entire quantity, what's in the bubble or the parentheses, is one factor. The factor is x plus 3. I know this is where it gets confusing because this one factor contains 2 terms. But that's okay. This quantity is being taken times this first factor. So those are the factors of your first term. Of the second term, we have this 5, so that is a factor because it's times this quantity. So once again, we have 2 factors here, 5 and this x plus 3. So the question is, what's the factor that both terms share? And we'd say, aha, both terms have this ugly x plus 3. That is the common factor. So that is what I'm going to pull to the front. Now it was in parentheses here, it needs to stay in parentheses because that is the factor together, that whole quantity. So you need the parentheses there. If I take out the x plus 3 of this first term, what am I left with? The x squared. If I take out the x plus 3 in the second quantity, what am I left with? The plus 5. You need the plus sign to separate your terms. Now we are in factored form because it's this factor times this factor. Everything that we have left here is multiplication. That means it's in factored form. Let's try one more of those before we move on to our next concept. So once again, the first thing that we're looking for whenever the directions say factor is your greatest common factor. This problem, like our last one, has some ugliness to it. But what you should notice is that what's in parentheses is the same in both of our terms. This has an x minus 7, this has an x minus 7. That is what's common, so I bring it to the front. Now I only write that once. Remember, this is the reverse of our distributive property. When we multiply both things inside, here we say they have a common factor. I'm going to write it as one factor in front, and the distributive property takes care of the fact that it's in both of them. This is why it's a little bit more compact of writing it, because I only need that x minus 7 once. If I pull out the x minus 7, my first term I'm left with the 2x, and in the second term I'm left with subtracting 3. Now we need that subtraction to separate the terms. And that's our final answer. Taking out the greatest common factor is very beneficial because it allows our numbers to get smaller in case we have to do another step with them. Because some of these put things together like that, which you need more than one term, or more than one factoring to do to get to your final answer. So this is taking out your greatest common factor. And then in our next video, we'll take an advancement from this into grouping when we have 4 terms.